Welcome back, students. This is our third and final video for today. We're going to talk a little bit more about single replacement reactions and predicting them, and then I'm going to teach you double replacement reactions. So I showed you how a single replacement reaction will only occur if and when the element in the activity series that is single is above the element that is in a compound. I want you to rewrite in your notes the list of metals. Remember, on a test you will be provided this list. You won't be required to come up with it on your own. Anyway, we're going to start out with lithium, and then below that is calcium, sodium, magnesium, aluminum, zinc, iron, tin, hydrogen. You say that's not a metal. Yes, it's not a metal, but it's positive, and hydrogen will switch places with a metal. So I'm going to put in here non-metal just so you know that I know it's not a metal and you don't wonder why it's in that list. Then keep going down, copper and mercury, and then the metals we like to wear: silver, gold, platinum. So if this is your activity series, this is from the most active to the least active. So the metal on the top, if it's single, can replace a metal that's in a compound in aqueous solution. Now what about, so those are the metals. What about the nonmetals? All right, so let's list this. The activity series for the nonmetals is much shorter. We know that fluorine is the most reactive nonmetal, so it makes complete sense that fluorine's going to be at the top of our list. Remember, it has an electronegativity of 4, so it really likes to pull electrons to itself. So if any element with electrons on the outside comes near it, it's going to react violently. So fluorine, chlorine, oxygen, bromine, iodine, sulfur. So this is most reactive to least reactive. I just have a quick question. Why in America do we say chlorine, bromine, iodine? Chlorine, bromine, shouldn't it be chlorine, bromine, iodine? Because where I come from, we say chlorine, bromine, iodine. They all rhyme, but here we say chlorine, bromine, iodine. Just curious, but that's not on your test. Okay, so that's the activity series for nonmetals. So I'm going to give you a reaction, and typically in a single replacement question, you'll be given the first half of the reaction. You need to, of course, recognize that it's a single replacement reaction. Now remember, the general form for a single replacement reaction is A plus BC makes B plus AC. All right, so, or that's if two metals are reacting. If two nonmetals are reacting, it would be A plus BC makes C plus BA. Now, if that won't make you feel like you're having a dyslexic moment, nothing will. But don't worry about it. You'll be real good at recognizing a single replacement reaction because you're just looking for a single element combining with an element in a compound in an aqueous solution. Okay, let's try this one. Bromine, let's not put its state. Bromine plus sodium iodide. We need a Roman numeral, we need a coefficient of 2 there. And then you just got this blank space here, and you are supposed to be able to fill that in. Now that might seem a little bit overwhelming, but you're a real scientist, so all you do is you look at this and you say, hey, this is a single replacement reaction, and this guy right here is a nonmetal, and nonmetals trade places with nonmetal, so I just need to see if the single guy, bromine, is above iodine. So I go and I look. Bromine is above iodine. See, I slipped into iodine. Bromine is above iodine. and therefore they're going to trade places. So you can finish this. Let's go ahead, put the I by itself, and then NaBr. Oh dear, now we have to make sure that ionic formula is correct. Let's just check quickly. +1, -1, we're correct. Charges balance. And then hopefully you're looking at that I and you know something's wrong. What's wrong? I is part of our group of elements that we affectionately call Brinkelhoff, so I needs to be I2. So yes, this reaction occurs. Oh, and we're going to balance. Done. So what I suggest you do is stop the video, write the first half of the reaction, and see if you can complete the reaction and balance it all on your own without any input from anybody else. Now, how about if I gave you this reaction? Cu, copper plus water. Now, if you think about your house, you may have something that's copper, and you're probably not afraid to wash it if you're a helpful person and you help clean up around the house. Why are you not afraid to wash it? Well, this is a single replacement reaction. This is an example where a metal is going to trade places with hydrogen. So let's look, and let's find hydrogen and copper, and guess what? Copper is below hydrogen in activity, so this is no reaction. And that, folks, is why you're not afraid to wash anything that's copper. It's not going to explode or fizz or disintegrate in your hands. Okay? So that's single replacement reactions and just a little bit of practice. Now let's move on and let's talk about double replacement reactions. Double replacement reactions. Now, if you know what a single replacement reaction is, you can probably guess what a double replacement reaction is. A double replacement reaction looks super duper complicated when you first stare at it. It's so long, and if you get overwhelmed by a lot of letters and numbers, you will probably feel a little bit overwhelmed when you see it. If you feel overwhelmed, you're probably looking at a double replacement reaction. But there's no reason to be overwhelmed. Let's go ahead, and I'm going to write this reaction down. I love this reaction. I had mixed up the stuff at school so that when we came, we could each do this ourselves because it's very rewarding and satisfying to watch. But instead, I'll link you to a video of it, and you can just watch it. And then one day when we get to come back to school, we'll do it in real life, okay? All right, so we have potassium iodide. It's in an aqueous solution. It's mixed with lead nitrate. This lead is lead 2 nitrate. It has a +2 charge. This is also aqueous. And it's going to form lead iodide and potassium nitrate. This becomes a solid, and this becomes aqueous. Okay, now let's see what happened here. Let's see if we highlight some of these. I'm going to highlight the potassium and the lead. Can you see what happened? Can you see how the potassium and the lead literally just traded places? You know what I would do if we were at school, right? I would have two couples standing there looking at each other, and then would do, I went to the movies with so-and-so, I went to the movies, and then, oh, I'd rather be with them, I'd rather be with them, would have you trade places. It's kind of like that terrible show that didn't stay on the air very long called Wife Swap, where the wives would trade places with each other and go live in another house. Couldn't pay me enough to do something so egregious, but never mind. It's kind of like Wife Swap, or you go on a double date and then you switch dates halfway through the movie, and then you go home and tell your friends all about the crazy night you had. Okay, so how do we know if this scenario is going to happen? Well, first of all, let's do this in letters. AB plus BC. Now, who's trading places? A and B are. So now, whoa, I messed up. Let's do this again. AB plus CD. Now these two guys are going to trade places, makes CB plus AD. That's a double replacement reaction. Okay? Now, three things have to happen. You know, it's funny, I'm holding up three fingers like you can see me. Three things have to happen in order for a double replacement reaction to occur. Because it's not like you can just mix two liquids and always get a response. You know that doesn't work like that. Only sometimes do you get a reaction. You've got to at least have a precipitate. Remember, that's our fancy word for a solid forming. And this one makes this beautiful yellow, satisfying precipitate. And you can watch it in slow-mo. I was going to have you guys video it in slow-mo one day when we get back to school in real life. Okay, so either a precipitate will form, or a gas will form, or a molecular compound will form. Now, what's a molecular compound? Remember, anything covalently bonded. So a compound made up of nonmetals. Now, if you're in honors, you have to be able to predict whether or not a double replacement reaction will occur. If you're in foundations, you only have to be able to recognize one and complete it. I won't have you predict one. Everybody, though, has to know whether or not a single replacement reaction will occur. So in my next video, it will be for honors only, and I'll show you how to predict whether a double replacement reaction occurs. Okay, now we need to go back to this reaction that we just wrote. I'm going to get rid of all my markings, or some of them, and we need to balance this. All right, so let's look here. I have two NO3s over here. I only have one NO3 over there. Let's put a 2. Okay, so now I have two Ks over there, so I'm going to put a 2 there. Okay, so now I have two Ks and two Is, two Ks, two Is. I have one PB over here. PB stands for lead, plum bum, lead. And I believe our reaction is balanced and we have all our symbols, and aside from it being a little bit messy, it's complete and we are good scientists. Okay, so this is a double replacement reaction. Let's do one more and then we'll stop the video. Okay, here's one. NaCl, aqueous. It's always going to be two aqueous solutions plus AgNO3, silver nitrate, also aqueous. Now, this reaction is going to occur because the silver chloride that forms is a precipitate. So all you guys have to do is switch places. So pause the video and see if you can finish the reaction on your own. Okay? Pause the video, finish it on your own. Okay? So hopefully you did that. Now I'm going to do it with you. These two guys need to trade places, wife swap, double date swap, worst night of your life, best night of your life, something. All these compounds are plus ones and minus ones, so making compounds is going to be a piece of cake. AgCl. This is a solid. I'll explain next lesson how we know that. And NaNO3 aqueous, and it's balanced. So hopefully you got that one right. That is a double replacement reaction. And that ends our lesson on predicting single replacement reactions and identifying and completing double replacement reactions.